In this video, we will learn about the process of factoring by using the greatest common factor. In mathematics, factors are numbers that can be multiplied together to get another number. For example, 4 and 5 are factors of 20 because 4 times 5 equals 20. A number can have many factors. For example, 1 multiplied by 18 is 18, 2 multiplied by 9 is 18, and 3 multiplied by 6 is 18. So 1, 2, 3, 6, 9, and 18 are all factors of 18. But why just stop at positive numbers? Consider that -1 multiplied by -18 is 18, -2 multiplied by -9 is 18, and -3 multiplied by -6 is 18. Thus, -1, -2, -3, -6, -9, and -18 are also factors of 18. Next, we'll discuss the greatest common factor, which is an important concept in factoring. The greatest common factor, or GCF for short, is the greatest number that is a factor of 2 or more other numbers. For example, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. The largest factor that is common to both 24 and 48 is 6. Therefore, the greatest common factor of 24 and 42 is 6. Next, we'll move on to factoring algebraic expressions. We can factor an algebraic expression by writing it as a product of 2 or more expressions. Consider the expression x to the exponent 5, which is equivalent to x times x times x times x times x. Note that x is multiplied by itself 5 times, so this expression contains 5 factors of x. As another example, consider the expression x to the exponent 2 multiplied by y to the exponent 3. This can be written as x times y times y times y. Here, x is multiplied by itself 2 times and y is multiplied by itself 3 times. Thus, this expression contains 2 factors of x and 3 factors of y. Let's try out an example. In the expression a to the exponent 4 multiplied by b to the exponent 5, there are 4 factors of a and 5 factors of b. Similarly, in the expression 2a to the exponent 3 multiplied by b, there is 1 factor of 2, 3 factors of a, and 1 factor of b. Both expressions have at least 3 factors of a and 1 factor of b in common. Thus, the greatest common factor of these expressions is a cubed b. Now we'll work through several examples. Let's factor the expression 15x plus 3. To do this, we'll look for the greatest common factor. To begin, let's look at the coefficients of each term. For the numbers 15 and 3, the greatest common factor is 3. Next, we'll look at the variables. Since the first term is the only one that contains an x, it is not common to both terms. Thus, the greatest common factor is 3. By factoring out the greatest common factor, the expression 15x plus 3 can be factored as 3 multiplied by 5x plus 1. The first term in the brackets was obtained by dividing 15x, the first term in the original expression, by the greatest common factor of 3 to produce 5x. Similarly, the second term in the brackets was obtained by dividing 3, the second term in the original expression, by the greatest common factor of 3 to produce 1. When factoring by the greatest common factor, we are really dividing each term in the original expression by the greatest common factor to express it as a product of 2 expressions. In the next example, let's factor the expression 16x squared plus 8xy. To find the greatest common factor, let's begin by looking at the coefficients of each term. The largest number that evenly divides into 16 and 8 is 8. Thus, the greatest common factor will contain a factor of 8. Then we'll look at the variables. Let's first look at the x's. The first term has an x squared and the second term has an x. Each term contains at least 1 factor of x, so our greatest common factor will also contain a factor of x. Finally, we see that only the second term contains any factors of y, thus the greatest common factor is 8x. To factor the expression, we divide each term by the greatest common factor, therefore the expression 16x squared plus 8xy can be factored as 8x multiplied by 2x plus y. The first term in the brackets was obtained by dividing 16x squared, which was the first term in the original expression, by the greatest common factor of 8x to produce 2x. Similarly, the second term in the brackets was obtained by dividing 8xy, which was the second term in the original expression, by the greatest common factor of 8x to produce y. Next, let's factor the expression 16a cubed bc squared minus 12abc plus 4b squared. To find the greatest common factor, let's begin by looking at the coefficient of each term. The largest number that evenly divides into 16, 12, and 4 is 4. So, our greatest common factor will contain a factor of 4. Then we look at the variables. Let's first look at the a's. The first term has an a cubed, the second term has an a, and the third term has no factors of a. Thus, the variable a is not common to each term and will not be part of the greatest common factor. Next, we look at the b's. The first term contains one factor of b, the second term also contains one factor of b, and the third term contains two factors of b. Each term contains at least one factor of b, so the greatest common factor contains a factor of b as well. Finally, let's look at the c's. The first term contains two factors of c, the second term contains one factor of c, and the third term contains no factors of c. Thus, the variable c is not common to each term and will not be part of the greatest common factor. Therefore, the expression 16a cubed bc squared minus 12abc plus 4b squared can be factored as 4b multiplied by 4a cubed c squared minus 3ac plus b. The first term in the brackets was obtained by dividing 16a cubed bc squared, which was the first term in the original expression, by the greatest common factor of 4b to produce 4a cubed c squared. Similarly, the second term in the brackets was obtained by dividing negative 12abc, which was the second term in the original expression, by the greatest common factor of 4b to produce negative 3ac. Finally, the last term in the brackets was obtained by dividing 4b squared, which was the third term in the original expression, by the greatest common factor of 4b to produce b. Have a question? Leave it in the comments below. If you enjoyed this video, be sure to leave it a like and subscribe to this channel for more.